Good evening, learners. I hope you are doing well. This evening we are going to be learning about the structure of an atom and the periodic table. This being the first topic in Form 2, Chemistry. We are going to start it out. And before we start, if you have never subscribed into our YouTube channel, subscribe at Top Grade Academy. Turn on the notification bell so that each and every time we upload a new video, you will always be updated. A lot more is coming. It will not just be mathematics, but we are also involving science or drawing science in board so that everything would run smoothly. So in this particular lesson, we are going to introduce ourselves to structure of an atom and the periodic table. This is the first topic in Form 2 work, where we are going to be discussing about the structure of an atom. We'll be discussing about the structure of an atom. The structure of an atom. And back in Form 1, we defined an atom and said that we defined an atom and we said that an atom is the smallest particle. An atom is the smallest particle of an element. We say that an atom is the smallest particle of an element that can take part in a chemical reaction. That can take part in a chemical reaction. In a chemical reaction. An atom is the smallest particle of an element that can take part in a chemical reaction. Something else that we need to understand about an atom before we draw the structure of an atom is that atoms of the same element are similar. 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 So if there are atoms of copper, that means all atoms of copper are similar to each other. If it is another example like hydrogen, all atoms of hydrogen are similar to each other. The next thing we need to understand is that an atom is made up of 3 subatomic particles. An atom is made up of 3 subatomic particles, namely, we have the protons, we have the neutrons, and we have the electrons. We have the electrons, we have the protons, the neutrons, and the electrons. We can now draw the structure of an atom. How does an atom look like? So before we draw the structure of an atom, so this is the structure of an atom. An atom has a central point, which we call the nucleus, where the protons and neutrons are, and now it has the other parts. The other parts. So it has a nucleus. That is the structure of an atom. It has a nucleus, and it has the part surrounding the nucleus, which we call the energy levels. Which we call the energy levels. Which we call the energy levels. That is the structure of an atom. So this is generally how an atom looks like. So the protons and neutrons are located in the nucleus. They are located in the nucleus. The protons and the neutrons are located in the nucleus. And the electrons are positioned on energy levels. Electrons are positioned on energy levels. Electrons are positioned on energy levels. So having the protons and the neutrons in the nucleus, our electrons are positioned in the energy levels. Our electrons are positioned in the energy levels. So those are our electrons. Those are our electrons. Electrons are positioned on the energy levels. So I want us to discuss about the charges of subatomic particles. Charges of subatomic particles. So what are the charges of subatomic particles? What are the charges of subatomic particles? What are the charges of subatomic particles? So to start with, number one, protons are positively charged. Protons are positively charged particles. Neutrons, as it is derived from the word neutrons, they have no charge. They have no charge. Number three, electrons, as they have just been derived, they are negatively charged. They are negatively charged. They are negatively charged. They are negatively charged. Electrons are negatively charged. So protons are positively charged. Neutrons, they have no charge. Electrons are negatively charged. So the next thing that we are going to be discussing is atomic number and mass number. Atomic number and mass number. Atomic number and mass number. So we will start with atomic number. What is an atomic? What is an atomic number? So atomic number is the number of protons. It is the number of protons in the nucleus of an atom. It is the number of atoms in the nucleus of an atom. It is the number of protons in the nucleus of an atom. Another thing that I want you to understand about atomic number or the proton number is that the number of protons, the number of protons and electrons in an atom are equal. In an atom are equal. So the number of protons, the positively charged particles, and the number of electrons, which are the negatively charged particles, are equal or they are the same. And this makes the atom to be electrically neutral. This makes the atom to be electrically neutral. Why electrically neutral? Because the number of protons and the number of electrons within the atom are equal. So after learning this on atomic number, we can mention something else on mass number. Mass number. So mass number is the sum of protons and neutrons in the nucleus of an atom is the sum of protons and neutrons in the nucleus of an atom. In the nucleus of an atom. So what does that mean? That means that the constituents of the nucleus, which are the protons and the neutrons, so given an atom, mass number will be equivalent to protons plus neutrons. It will be equivalent to protons plus neutrons. So these two are the ones that contribute to the mass number of an atom. And the mass number of the atom is the mass weight. It is the mass weight of the atom. The mass weight of the net weight. Let's use the word net weight of the atom. It is the protons plus the neutrons. These two are the ones that make up the mass number. So we can check out on representation of mass number and atomic number. 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 So, talking of representation of mass number and atomic number, what are we trying to drive, or what point are we trying to drive? This is what we are trying to communicate. For instance, if we have an element A, if we have element A, there is nothing like element A, we are just using it as a reference. So for us to represent them, we have element A, we have X, and we have Y. The superscript, the one above, is what represents the mass number. The superscript represents the mass number, while the subscript represents the atomic number. While the subscripts represent the atomic number. So for us to represent the mass number and the atomic number on an atomic structure, we have the number above, which we call the superscript, is what represents the mass number, and we have the subscript, it is the one that represents the atomic number. So atomic number, don't forget, is the number of protons, and this one is the number of protons and neutrons. So if you want to determine the number of neutrons, you are going to take the protons plus neutrons, which is the mass number, minus the atomic number, and you are going to be left with neutrons. That is how we determine the number of neutrons, and this is how we generally represent the mass number and the atomic number. So by having that, we can discuss something on isotopes. Let's discuss something on isotopes. Relative atomic mass and isotopes. Relative atomic mass and isotopes. Relative atomic mass and isotopes. So before we get to relative atomic mass and isotopes, I want us to check out on the first 20 elements. The first 20 elements. The first 20 elements. Why do we call them the first 20 elements? Because they begin from number 1 to number 20, in which these numbers represent the number of electrons. So starting with the first one, number 1 of them all we have is hydrogen, whose symbol is He. Number 2 we have is helium, whose symbol is, hydrogen is H, helium is He. Number 3 we have lithium, in which lithium sign is Li. Number 4 we have beryllium, in which the symbol is Be. Number 5 we have boron, which is B. Number 6 we have carbon, which is C. Number 7 we have nitrogen, which is N. Number 8 we have oxygen, which is O. Number 9 we have fluorine, whose symbol is F. Number 10 we have neon, whose sign is Ne. Number 11 we have sodium. Sodium is Na. 12 we have magnesium. Magnesium is equal to Mg. 13 we have aluminium. Aluminium is Al. Number 14 we have silicon. Silicon is Si. Number 15 we have phosphorus. Phosphorus is P. Number 16 we have sulfur. Sulfur is S. Number 17 we have chlorine. Chlorine is Cl. Number 18 we have argon. Argon is Al. Number 19 we have potassium. Potassium is K. Number 20 we have calcium. Calcium is Ca. So all these elements we have them with their symbols. So if it is the number of electrons, if we are talking of the number of electrons, hydrogen has 1 electron, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, calcium 20. So those are the first 20 elements. They have the same number of electrons. They also have the same number of protons. So even if it's the number of protons, they are the same. Remember we said that in a neutral atom, the number of electrons and the number of protons are equal, and that is what makes the atom to be electrically neutral. So having done that, I want us now to proceed to relative atomic mass and isotopes. 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 And we can begin with isotopes. What are isotopes? So isotopes are atoms of the same element. They are atoms of the same element. They are atoms of the same element with the same atomic number, with the same atomic number but different mass number. With the same atomic number, underline the word atomic number, same atomic number but different mass number, It can also be defined as atoms of the same element, or they have the same number of protons. They have the same number of protons but different number of neutrons. So they are also atoms of the same element with the same number of protons but different number of neutrons. For example, we have chlorine 35 and chlorine 37. We have chlorine 35 but chlorine 37. That simply demonstrates that chlorine exists as isotopes. Chlorine exists as isotopes. So, relative atomic mass of isotopes. Relative atomic mass of isotopes. So we can simply define this as relative atomic mass is the average mass of an atom, as compared to that of carbon 12. So relative atomic mass, how do we find the relative atomic mass? Relative atomic mass, our RAM is equal to mass of isotope multiplied by percentage abundance over 100. Mass of isotope multiplied by percentage abundance over 100. Mass of isotope multiplied by percentage abundance over 100. So we are going to respond to this question on how to determine the RAM of elements or RAM of isotopes. We have a question here, and this question reads: boron has two naturally occurring isotopes. Boron has two naturally occurring isotopes. isotopes. It has two naturally occurring isotopes with the natural abundance. With the natural abundances shown in the table below. Shown in the table below. So we have isotope and natural abundance. We have isotope and we have natural abundance in terms of percentage. The first one, we have boron with a mass of 10, whose percentage is 19.9%. Then we have boron 11 with a mass of 80.1%. Then the question is asking, calculate the RAM of boron. Calculate the RAM of boron. Calculate the RAM of boron. That question has 3 marks. Calculate the RAM of boron. Calculate the RAM of boron. So for us to calculate the RAM of boron, we need to be aware that the formula for RAM, we've just said that the formula for RAM is equals to mass of isotope multiplied by percentage abundance over 100. So our RAM will be equal to the mass of isotope, here is 10, multiplied by the percentage abundance of this one is 19.9 over 100, and because there are two isotopes, it will be plus the second one, mass of isotope 11 times percentage abundance 80.1 over 100 over 100. And once we do that, we have our RAM as. So if you solve all of this in a calculator, you are going to get 10.8. You will get 10.8 as your RAM. 10.8 as your RAM. Let us do example 2. Example 2. Question 2. On RAM, we have lithium has two naturally occurring isotopes. Lithium has two naturally occurring isotopes. Lithium has two naturally occurring isotopes. We have number 1, seeds, lithium seeds, with a percentage abundance of 7% abundance. Close the bracket. And lithium 7 with a percentage abundance of 93%. 93% abundance. Calculate the RAM of lithium. Calculate the relative atomic mass. Remember, the relative atomic mass is the same as RAM. Relative atomic mass of lithium. 3 marks. 3 marks. 3 marks. That is what we are supposed to determine. So, in this case, we said that the formula is RAM is equal to mass of isotope times percentage abundance over 100. So our RAM will be equal to the mass of the first isotope is 6 times percentage abundance is 7 over 100 plus the mass of the second isotope is 7 times percentage abundance, which is 93 over 100. And if you do that, at the end of it all, you are going to get 6.93. The RAM will be equal to 6.93. So we are going to end our first session there. Tomorrow in our second session, we are going to learn on energy levels and electron arrangement and electron arrangements. Energy levels and electron arrangements. Energy level and electron arrangement. So that is what we are going to do tomorrow. Have a blessed night. Bye.